Folks, welcome back to ESO's Lab Episode 3. As I mentioned in the last video, we're getting started on a very fun project. What is it, you ask? Well, we're going to take this dumb heater and turn it into an automated smart heater. Alright, so if you plan to follow along with this build and build your own smart heater, here's what you're going to need. An Arduino of some sort. Any Arduino will do. These are Uno clones. Here's a real Arduino Uno. It is part of the starter kit and has its own breadboard built into it, and this size of breadboard is actually all you're going to need to prototype out this project. But you could be using, Mini, Pro Mini, little megas, whatever you want to use for your Arduino microprocessor is up to you. Secondly, you're going to need a temperature sensor. Something that's going to detect the temperature in your room. So this could be any number of temperature sensors, but for this project I'm using a small, looks like a little transistor. It's a TMP34GZ. This one actually came with the Arduino starter kit, so if you've got that, you're all set. Otherwise, you could use any number of different sensors on the market. If you don't have something like this with the breadboard built into it, you're going to need a breadboard to prototype out your circuit. You're going to need an LED. That's just going to provide us a logic test or some function to show us that the thing's actually working temporarily. You're going to need, because we're working with 120 volt AC, you're going to need something that's going to allow the Arduino to function with that level of voltage and current. So you can either use a separate little relay like this. You can get them just the bare relay, something like 20 cents or whatever. Or you could be using a relay breakout module. These come in single, doubles, triples, quadruples, all the way up to like 8, different relays. But they offer some extended isolation from the circuit that you're controlling. Some safety features and LEDs to indicate when it's working, etc., and easy ways to connect them. So recommended if you have one of these, you can use one of those, but the bare relay will work as well. Just make sure it's rated for however many amperage your heater is going to take. Or use, I should say. The last thing, of course, is power supply. So if you're using an Uno like this, you could power it via the barrel connector, or connected to a 9-volt battery or any other kind of power supply you have. Otherwise, you could power it from the USB directly to the Arduino. I'm going to use this little breadboard power supply connector that powers the breadboard directly, and that's just connected to a variable bench power supply that I have. So that's another build we'll talk about another day. And lastly, you're going to need a heater. So in this case, I've just picked up this just a basic heater, high, low, off, fan only. It can be a nice little ceramic unit that you've got. It can be something like that, an old-fashioned just wire element heater. Anything that you've got, you can use. Should be functional with this. So anyway, there it is. That's the parts that you need. Alright, let's get started with our build. So for the prototyping phase of this, you're not going to need an external power supply. We'll just simply use the USB power coming from either the FTDI breakout board or the USB cable directly if you're using your standard type Arduino. I'm using the Pro Mini, which is the Atmega 328 chip. Very similar. It's functionally the same as an Uno. Okay, so I've got that plugged in. First step is let's get power to even though we are going to get power from the USB, the rest of the devices are going to take power from the Arduino as well. So we connect the ground pin to the negative rail. Okay, and then we're going to take the VCC pin, connect that to the positive rail. Okay, so our power is connected to the breadboard rails. Alright, next step is our temperature sensor. So this is the TMP36GZ. You can get them for about $1.50 anywhere online. They're pretty cheap. You can even get them cheaper than that. It is a great little unit going from left to right. You've got power, signal, and ground. So I'm going to connect this in a way that's going to allow me to touch it. Okay, so I'm just going to put it on the edge of the breadboard so that when we've got the rest of the stuff connected here, I can still grab it with my finger. And that just allows me to quickly change the temperature of that sensor so I can see the changes and make sure that it's all working correctly. So as I said, left to right, power, signal, and then ground. So the rightmost connector going to the ground rail. Okay. Leftmost connector going to the positive rail. Okay. And the middle one is our sensor. So in this case, I am going to use analog input A0. This does just output an analog value, which you can then break into voltage and then convert from voltage to a temperature. So I'm going to use a purple pin, and we are going to put that into A0 on the Arduino. Okay, so I've got my signal wire going from A0, reading from that sensor. I've got my power to the sensor. I've got the power to Arduino. The last thing that we are going to do is put in an LED. Now the LED is going to just give us an indication that it's working and functioning. It's only going to be for testing purposes at this point. Eventually, the output pin that we're connecting the LED to is going to be connected to the a relay to turn on our other device. But we're going to get the rest of the code working and all that stuff first, and you'll see it's much easier to just have a light indicating that it's on or off versus actually putting the heater on and off. Alright, so as always with Arduino, you need to connect a resistor in series with the LED so that it prevents it from drawing too much current. In this case, I'm going to put this into digital output 10, and that can really just go anywhere on your board. And then you're going to take the negative leg, the shorter leg. Also, there's a flat part on the LED that shows you the negative. So I'm just going to go from there and with the negative leg into, actually, let's reposition this here so we got some room here. Okay, so negative leg into the negative rail, positive leg connected to the resistor. There, and that's it. So what this is going to do, this is our Arduino, it's connected to power, it's connected to this temperature sensor, to an analog port on the Arduino. It's going to allow it to read the values coming from that sensor. And then we have an LED connected to a digital output that's going to allow us to turn that LED on or off. And that's it. Let's get to the code. Alright, so here we have our Arduino IDE. I've just opened up a new window, so it's just the, the fresh, bare basic code on here. So what I like to do, and it's good practice, this is the first time I'm using this little Pro Mini, so I'm just going to go to the examples, go to basic, and then choose blink. And that's going to open up blink. I've got my board on COM7 at Mega 328 Pro or Pro Mini. Good. All right, so I'm going to go ahead and upload that. So it's compiling the sketch, and it is loading. Good, it's done uploading. All right, so then I can just take a look. I see my LEDs blinking on and off. Okay, so this board looks good. All right, so we have got a blank screen here. So the first thing that we're going to want to do, going above the setup, I'm going to set a constant variable of type integer, and I'm going to call it temp sensor. and that is going to be on analog input. I think we said 0, right? Yeah, we're on analog input. 0 is where the signal pin from our temperature sensor is going. So I'll just say initialize temp sensor input variable. Okay, and then we're going to set another integer. Actually, this can be a constant integer as well. Constant int, and this is going to be our set temp. And that we're going to set the temperature at 20 degrees. So initialize set temp. So this will be our target temp variable. Okay, and then the next one is going to be constant integer relay pin, and that is going to be in this case 10. I've hooked up the resistor and the LED to 10, so that's an LED and a resistor now, but it's going to be the relay after. It's going to be the signal that fires the relay on and off to control 120 volts AC to our heater. So for the moment, it's just the bare relay and an LED, or the bare pin connected to a resistor and an LED, just to give us a visual indication of when it's going on and off. Make sure our code's working before we start setting it all up with AC wiring. Okay, so initialize relay pin variable. Okay, good. All right, so that's all we need to set up. So this is just a comment that comes in handy. We can take that out. So the first thing we are going to do is set the pin mode on what we're calling that variable as relay pin, or pin 10, to output, just so that it knows it is an output, and that changes the way it connects either to pull up or pull down resistor internally within the Arduino or the Atmega microprocessor. All right, the next thing we're going to do is, just so that we can monitor the actual readings that are coming off of the temperature sensor, we are going to initialize the serial display. So we can open up the serial window, which is right here. And so that is going to be serial.begin. Set it at 9600 baud. Now, you don't need to initialize a library or anything for this, because it's just built into the IDE, I believe, or by default has that functionality. And then just for shits and giggles, I'm going to say serial print line, and I'm going to say smart heater initialize. So this is going to just print out. It's going to actually, you know what I'm going to do? I'm going to put a version in there too. So let's call it 1.0. So what this is going to do is, every time the Arduino boots up and you're, monitoring the serial output from it, it's going to show you just a brief splash that says Smart Heater Initialize version 1.0. So this will, first of all, tell you it's working, it's starting, the program's working successfully. And secondly, it'll tell you what version that you've loaded on here. So you might go through several iterations, changing the code and then making the changes, and maybe you forgot to upload it, and then you're looking at it and you're saying, oh, wait, hold on a sec, this is still the old one, right? So, you have to change that every time just to make sure you're up with the changes. But yeah, that's it there. So that is going to give us that output. I think that is all the setup we need to do. We've got our output, yep, we got our serial. Okay, all right, so code that we want to run all the time. So within our loop, we are going to initialize a value on the, we're going to call it sensor val, and this is going to be the output from that sensor. So we need to do an analog read like that, and what did we call our variable? Was right here, temp sensor. So we're going to do an analog read of temp sensor. Now we could just say analog read A0, but in this case, if we ever want to change that, then we only have to change it in one place at the top. So that's the whole point of setting these constant variables up here. Okay, so analog read of that temp sensor. So this is going to create the variable sensor val, and its value is going to be the output of analog read from pin A0, right? That's going to store it in there. Okay, so we can see what that is after it's done the read by just doing a serial print, and then let's put what's that called? It is we called it sensor val. So serial print sensor val, just like that. All right. So I am going to upload it. So you can hit the check sign if you want. Oh, it's asking me to save. I'm going to call this smart heater. Let's call it phase 1. Okay. Okay, so it's compiling the sketch. Good, everything compiled good, so we'll just do the upload. So it's now sending that data to our Arduino. And I will confirm, yes, the lights are flicky flashing and things are going good. It says it's done uploading. Okay, so we can open the serial monitor. All right. Okay, so the first thing we need to do here, which I forgot about, is let's add a delay after the serial print. Delay of 1,000 milliseconds. Let's show what happens. Okay, let's go ahead and upload that. That's too much crap coming out, just spewing out of there. Okay, so there it is. Smart heater initialized, and now it's 141, 141, 141. I'm going to do something else here. Instead of saying just serial print, I'm going to say serial print line on this. And let's upload that. Okay, so that is uploading. Lights are flicky flashing. And there we go. Okay, so there. So now every time it's going to print that as a line. So that just means it does a character return after whatever value it's printing. So it just appears on a new line. So you can see it's 142, 141. I'm going to actually touch that now. Okay, so I'm touching it. It's going up to 143, 144, 145, 145. Okay, so 146. So it's bouncing around up there. Okay, so that obviously is reading well, and I think 1 second is good for us here. Okay, next thing we're gonna do is let's format that a little differently. I'm gonna take out the line, and I'm gonna put in here. Actually, you know what? I'll leave that. What I'm going to do is I'm going to put another serial dot print ahead of it, and in here I'm going to put I will call this the sensor value. Put a space. Okay, just like that. So we've got a space, and then it's going to print our sensor value. Okay, let's go ahead, upload that. You can see our serial output is coming up there. There it is. Smart heater initialized version 1. Sensor value 141, 142. Okay, great. So now we need to take that sensor value and convert it to a voltage. Okay, so the way we do that is going to specify another variable. And this is going to be a float because we don't necessarily know how many decimal places or the length of that, so it's going to store that variable as a float value. We're going to call that voltage, and that is going to be a product of the sensor value, and because the Arduino has a 10-bit analog to digital converter, that means it can do 1024, so values 0 to 1023 as increments for that gradations within that reading. So we're going to take that sensor value and divide it by 1024. So that is going to give our voltage in terms of gradations on the analog read. And then we are going to times that by 5.0 because we're working at 5 volts here. So that is going to give us the voltage. Okay, so sensor value divided by 1024 times 5. So let's do another serial print. So you know what I'm going to do is just copy this line, Control C, put it here, Control B, take out the space, and we're gonna put this as voltage value. Okay, and then so that is going to be voltage. So we want it to print the voltage. All right, let's go ahead, bang that through to the Arduino. It's uploading. Okay, it's done uploading. There it is. Oh, voltage value. You know what? I made a mistake here. The mistake is that I have to do this is that you have to put this in the decimal place when you're multiplying it for a float value. So hold on, let me just correct that. Let's upload that. Okay, it's uploading. Lights are flicky flashing. Okay, there it is. All right, cool. So now we've got same thing, 0.69, 141. We got our delay. Okay, good. All right. So now we have to convert that voltage into temperature, and we're going to do it temp Celsius. You can do it Fahrenheit if you want. I'm going to do it Celsius because I'm in Canada and we use the metric system here. All right, so again, let's do another float. Spell it correct, and we're going to call that temp. And that is going to equal the voltage. Okay, yeah, one thing about this sensor, this temp36 sensor that I'm using, is there's a bit of an offset. So it uses some voltage in order to get its reading, so we have to accommodate that. And it uses half a volt or 500 millivolts. In this case, because we're working in volts, the calculation here is giving us volts and not millivolts. We're going to use minus half, so minus 0.5 volts off of that. And then to get Celsius, times that by 100. So this, I mean, obviously the sensor is designed to work in Celsius, so it's time 100. That factor is going to be something else when you have to do some other math. It's maybe I'll look it up just for shits and giggles later to see what's going to be to get the Fahrenheit reading, but for now I'm just going to leave it as Celsius. Okay, and then I'm going to copy this line again, pop it in there. So this is going to be the temperature. Temperature space, temperature colon space, and then this variable is temp. Let's upload that bad boy. There it goes. Lights are blinky blinky. All right. And there it is. So we have a temperature of 18.36 in my office right now. Yeah, 18 degrees. I'm just holding my finger on it now so you can see it's going up to 21, all that kind of stuff. Good. Okay, so this is now reading the temperature. We are converting that to a voltage value, and we are converting the voltage into a temperature value. So what's left? Well, we have to make this thing do something based on those temperature values. So we are going to come in here, and I am going to say, because our set temp is 20, okay, so I'm going to say if set temp, no, pardon me, if the temp is less than set temp, brackets, blah, blah, blah. Actually, we don't need that. We need one of these dealios because we're in an if loop. So I am going to say digital write a relay pin high. Okay, so if it's going to say if the temperature goes below where we've set it, so our desired target temperature, set that relay pin high. Okay, and we go. Now we will file that and upload it. Lights are blinky, blinky, blinky. Good. Okay, so the temperature, as we had noted, or and you can see it here, is 19.82. We have the set temperature of 20. Let's see. Can you see this here? Okay, let's go big on it here for a second. Okay, so here's our Arduino. It's got our board on here, and that LED light is on. So if I hold this now, and it goes oh, you know what? Okay, so we want it to shut off if it gets to our set temperature, but we haven't put uh, that in there. We haven't put any instructions as to shut it off. So it turned it on when when it restarted. It wasn't on. So now we have the yellow LED on. But yeah, we need to say if the set temperature is greater, then shut it off. So let's put some code in for that. Let's put an if else in there. So well, we could do it as a separate if. Okay, temp greater than the set temp. Then we want you to do this digital write relay pin low. Okay, so check it. Yep, compiles good. Upload that bad boy. Okay. Okay, it's done uploading. There it is. She's awakened. Okay, so we can see that there. Let's go to Biggin's screen. Okay, so this is saying 19.82, so it's got to go to 21 at a minimum, right? Because it's got to be greater than. So if I'm holding, look at that, boom, LED off. We went to 20.8, so it's above that. Now I'm going to take my finger off and let it cool back down. It's 21.78, 20.8. Blow it a little bit. It's taking a while to come down. There's some minor fluctuations. That's just a product of the sensor and some. Oh, so there it is. Okay, we're now. No, there it is. LED on. It sees that it's below the temperature, and now there's that slight on-off going on because it's just fluctuating between that the threshold of what that temperature is, and we'll accommodate that. The fluctuations there and account for that in later versions of the code. But there you have it. We have written the code. It is taking input from that sensor. It is turning that on. Hold my temp sensor on here so temperature cranks up. Boom, LED is off now. So, hey, works great. Anyway, there it is. So, in the next episode, we will go further with it. We are going to set up a relay, set up some other variables, as well as some ways to change our target temperature. It's no fun just having one set temperature. Maybe we want it colder, maybe we want it warmer. So we're going to set up some switches at input to alter the variable for our set temperature. And we're going to hook up a screen so we can actually see that without serial input. So if it's plugged into something or connected to our heater, it's going to have its own display. Eventually, we're going to give it some infrared control so you can use the remote to increase and decrease it from across the room. And a few other little things. So it's going to be fun. Lots of places we can take this project to make it even more interesting. Thanks for watching, and we'll see you next week.